Hi guys. Let's do some PYQs of geometry from the last 5, 6 years. And this is level 2. And I'm assuming that you've already been through the foundation level 1. And after this, go for level 3 advanced questions. Let's go with question number 1. A circle of diameter 8 is inscribed in a triangle ABC where angle ABC is 90 degree. So ABC is 90 degree. And there's a circle inscribed in this. If BC is 10, find the area of the triangle. I need AB for area, and it is saying that diameter is 8, so radius is 4. I think whenever you get small r or the in radius, the one thing that should come in your mind is small r is equals to area upon semi-perimeter. So and I need area directly and I already have R. So I need semi-perimeter. I need these two, right? And let's assume this to be X and okay, let's take this to be B and this to be C. I already know that 10 square plus C square is B square or 100 plus C square is B square. This is one that I know. And I know semi-perimeter will be 10 plus B plus C by 2 if I put it here, but I don't know area. Find the area, okay. B square minus C square is 100. S can be written as A plus B plus C by 2. Okay. 4 into S. So area is 2 into 10 plus B plus C. Also, can I write area as half into base into height? So 5C. If you equate 5C is equals to 20 plus 2B plus 2C or 3C is equals to 20 plus 2B. This is 1 and this is 2. I'm interested in C. As soon as I get C, I can get the area. Let's eliminate B. So C can be written as 20 plus 2B upon 3. Sorry, I need to eliminate. What do I need to find? I need to find C. So I need to eliminate B. So 3C is 20 plus 2 and B can be written as, let's put it there. B can be written as 3C minus 20 upon 2 minus C square is equals to 100. So if I take multiply everything by 4, 9C square plus 400 minus 120C minus 4C square, and that will be 400. So we are on the right path, looks like it. 5C square is equal to 120C, or C is 120 by 5. 5 to the 10, 24. Now I've got C. I know area is 5 times C, or basically 120. So it got already eliminated. We knew Pythagoras theorem, we knew this theorem, we knew area of a right triangle is half AB. Just keep on creating whatever you know and question will eventually get solved. Question number 2. In a right angled triangle ABC, that means B is the right angled, okay, ABC. Altitude AB is 5. Base BC is 12. P and Q are 2 points on BC. On BC, P and Q are 2 points such that the areas of triangle ABP and ABQ are in AP. If the area of the triangle ABC is 1.5 times the area of triangle ABP. Find PQ. So whatever we need to find, let's assume it as X. Okay. And we know this BC is 12, right? So one thing that I know for sure is triangle ABC is half into base into height or 30. So triangle ABC's area is 30. Okay. ABP is 30 upon 1.5 or 300 by 15 or 20. Okay. Now this area is 20. This whole area is 30. Can I assume these three areas as A minus D because it's an AP, right? So A minus D and A plus D, where middle term is ABQ. This is ABC and this is ABP, which now I know is 20. This is 30. This has to be what? 25 because it's an AP. Now this total is ABP is 20 and this ABQ is 25. So this is 5 and ABC is 30. So now it looks like an AP. Now I can simply say area of APQ is half into base into height. Height is 5 and APQ is 5. So X should be 2. सेकंड का आंसर होना चाहिए 2. या गुड क्वेश्चन दो. Question number 3. In triangle ADE, because it is right angle triangle, two legs are 28 and 45. When it says legs, it means other than hypotenuse. Find the in radius of this triangle. Is it like a right angle triangle 28 square plus 45 square, or can I see this as 3 into 7? No, doesn't look like it. Is it? No. I can totally find AD, and as soon as I know AD, I know area is half into 28 into 45, and I know semi-perimeter also I can find in radius. So this is the right way. Can I write it as 28 plus 45 whole square minus 2 into 28 into 45? 8, 9, 10, 12, 13, 73 square minus 2 calculative. Doesn't look like a pair though. 9, 5. Let's not waste time. Let's calculate. 28, 28, 8 to the 64, 8 to the 16. 16 plus 6 is 22, 8 to the 16 to the 4, 5. 784. 45 square, I guess you know this trick that anything, if you multiply, then this will be 4 into 4 plus 1, which is 20. So 2025. Anything which is like in this way, x into 5 into x into 5. So always 25 and this will be x plus 1. X into x plus 1. So 45, so 4 into 5, 20. This is one of the tricks. So 2, or you can just multiply normally, it doesn't matter. 2809. This should be a perfect square. 9 है तो 13 is too small. Let's do 23. 3 to the 6 to the 4. 5 to 9. Much more than that. 33. Let's try 43. Yeah. 1849. Still less. Let me try 53. 3 to the 9, 5 to the 15. 15, 25, 26. 2809. Yes. 53 square this is. So this is 53. Now simply let's find the area also. This is 14 into 45. And semi-perimeter will be 53 plus 8, 9, 10, 12, 13, 73. by 2, 7, 8, 9, 10, 11, 12, 126 by 2 or 63. So now I know semi-perimeter is 63, R I don't know, and area also I know 14 into 45. So R is 14 into 45 upon 63. This should get cancelled. 3 ones are 3, 5, 21, 7, 14, 21. So we are on the right path. And 5. 6, 5 2s are 10. R should be 10. Third C. Yeah. Little calculative, that's all. Otherwise, it's directly very, very solvable. Something to definitely go for. A triangle has sides 10, 6, and 8. As soon as you see 10, 6, and 8, it's a no-brainer. It's a Pythagoras uh, triplet. So find the in radius. Again, area is half into base into height. So 6, 4 is 6, 12, 18, 24. Semi-perimeter is 14, 24 upon 2 or 12. So R is 2. So there can be this type of easy questions also, and just about your speed. Regular polygon A and B who have the number of sides in the ratio 1 is to 2 and the interior angles in the ratio A. Now you know interior angle, right? N minus 2 upon n into 180 degree. This is internal angle of a regular polygon. It is saying that A and B have the number of sides in the ratio, let's say x and 2x, and the interior angles are in the ratio 3 is to 4, let's say 3y and 4y or n. Find the number of sides. So directly substitute. I know that number of sides are x. Then this is the each internal angle. Number of sides are 2x. So this is the internal angle. And this ratio of internal angle is given as 3 by 4. X minus 2 upon x minus 1 is 3 by 2, or 2x minus 4 is 3x minus 3, or x is minus 1. This is not possible. Sides are in the ratio 1 is to 2. Internal angles are in the ratio 3 is to 4. So x minus 2 upon x into 180 degree. 2x minus 2 upon 2x होगा ना. Number of sides are 2x here. So this 2 will come in the numerator and this will be 2x minus 4 into 2, 3x minus 3, this is 4x, so x minus 8 plus 8 minus 3, 5, 6, 7, 8. Find the number of sides of B. So x is 5, number of sides of A is this, number of sides of B is this. But if the option was 5, you would have uh, checked on 5. So be very careful what it is asking. Question number 6, ABCD is a trapezium in which AB is parallel to CD, obviously, if it's a trapezium. So this is how it looks like. If these two were parallel, you would have drawn differently, or you would have marked ABCD differently. The sides AD and BC, AD and BC, when extended, intersect at E. AB is 2, CD is 1. So as soon as you get AB and CD like this, it is ABCD, because AB is given as 2 and CD is given as 1, and it is saying that the sides AD and BC when extended intersected E. Okay, this is still correct. And the perimeter of ABCD is given as 6. So it's not saying it's a regular one, but I know AD plus BC is definitely 3. This I know. Find the perimeter of the triangle AEB. Okay. If I know the sum of these two sides, I can get the perimeter. See, this is actually a triangle where these are ratio in 2 is to 1. These are all similar triangles. And this is also in the ratio 2 is to 1. So these two will be equal. These two will be equal. So basically answer should be 6. Why? I need to find the perimeter. So AD plus DE, EC plus BC plus 2. I need to find AD and DE are equal. So twice of AD. Similarly, EC and BC are equal. So twice of BC plus 2. This is 3. So basically, not 6, sorry, 8. You have to solve properly to get it. 6 should be C. Yeah. Very easy questions. You have to like really draw and things will pan out. Question number 7. ABCD is again a trapezium. Draw anything, then we will see what the question is saying. P is the midpoint of CD. Midpoint, good. Draw such that ABPD is a parallelogram. Okay. And triangle BPC area is given or what? Is the difference between the area of ABP, this minus triangle BPC is 10. Let it be delta 1, delta 2. So this is given as 10. Find the area of the trapezium. This we need to find out. Okay. What do we have any information? No. Can I say this is half D1, D2? This is trapezium. Since this is given as midpoint, let's see x. This will be 2x. This will be also x. So area of trapezium, half sum of parallel sides into h. I'm just playing around. Let's see. And this also parallelogram area is root 3 by 4. A square is 1 because these are all equilateral. No. In parallelogram, if you look at it, this is x, right? And this is also x. But we don't know if it is a regular one, but this is a parallelogram. A, B, P, D. Not rhombus. Otherwise, I would have assumed all of them equal. So I can't really say that these are two equilateral triangles. We don't know that if this is equal to x. Hmm. I need to find out this. So I need to find x and h. And what else do I know? I know this difference. This minus this. If I assume it to all be three similar triangles, it would have been very easy. This plus this and these are equal. And I would have said that this is twice of this triangle minus this triangle. So every other triangle, this is 10, this is 10, this is 10. So answer should be 30. That's what I'm assuming. I would have marked C, assuming this. Doesn't matter. But let me put in some more idea. Let's see. Because it's a parallelogram. And these two areas will definitely be equal. Because it's a parallelogram, this angle will be definitely equal to this angle. And this is a midpoint. So these two are equal. And it's a parallelogram. Now, otherwise, if it was rhombus, I would have assumed these two as equal. And then I would have assumed that these three are equal, so equilateral. But this area will be half into x into h plus half into x into h. Correct. See, this I can do, right? Area of this plus area of this. This is the area of the parallelogram minus, again, hey, I got it, x into h. See, this is how you got to prove that every area is 10, 10, 10. So half into x into h is 10. Put it here, 3 into half into x into h for 30. a quadrilateral ABCD is inscribed in a circle such that question number 8, let's say there's a quadrilateral ABCD such that AB is to CD is 2 is to 1. AB is bigger, right? A, B, C, and D. Now it is saying that AB is twice of CD and BC is 5 is to 4. AC and BD intersect at point E. Okay. Find AE upon CE. Right. We'll use similarity. Now, if you look at it, this angle and this angle should be equal. Correct? This angle and this angle should be equal. And so this angle and this angle will be equal. So from double A similarity, can I say triangle ADE will be similar to triangle ADE BCE? So can I say that AD, because I know AD and I know BC and I'm interested in the diagonals. I'm interested in AE and CE. So I should keep my answers here only. So in these two triangles, if I take AE, then I have to take in this triangle, I have to take BE. Why? A is opposite this angle, so BE is opposite this angle. That's why these two will be similar. And AD, I know. BC, I know. Now put BE upon AE as BC upon AD, which you know is 5 by 4. This is 1. Now similarly, if you look at, I use these two triangles, let's use these two triangles. This angle will be equal to this angle and this angle will be equal to this angle. So these two are similar in that way. Triangle AEB is similar to triangle AEB, I'm saying, and I'm taking A. So DEC. This is very important. The sequence A and D are equal. So A and D angle, this angle is equal. So I will go AE and DE and then CB again. C and B will be equal. That's why. So again, in this, I know these two. So I need to use AB and I definitely you need to use DC. And I'm interested in AE and EC. So I will take AB upon AE. AB upon AE is equals to CD upon EC. Or EC upon AE is DC upon AB, which is 1 by 2. I'm interested in AE upon CE. So AE can be written in terms of BE and EC can be written in terms of AE. Wait, AB and DC is fine. AE, sorry, this will not be EC. I am taking AB and AE, so I have to take CD and DE. Right? So from here, if I have to find AE, I can write it as 4 by 5 BE and CE from here. But I should find something in BE terms because this is BE. BE is involved here. I should also involve BE here. Can I do that? AB upon AB upon AE I'm taking. Instead, I'll take AB upon BE. So there DC upon, now that I've taken BE, I have to take EC. Correct? I hope this is clear. AB upon BE. So CD upon EC. So AB upon AB will go in denominator and EC will come up and BE will remain here. So EC upon BE is actually half. Now if I put EC as BE upon 2, 4 by 5 into 2, 8 by 5. AE upon CE, 8 by 5, 8A. Yeah. Let's go question number 9. In a triangle ABC, angle BCA is 50 degree. D and E are points on AB and BC. Sorry, AC. Such that AD is equal to DE. What? Okay. F is the point on BC. Such that BD and DF. BD, F is a point on BC, so that BD is equals to DF. Let's redraw. In a triangle ABC, angle BCA is 50. A, B, C. This is 50. D and D is a point on AB. E is a point on AC, such that AD is equals to DE. Now this looks good. F is a point on BC, such that BD is equals to DF. BD is equals to DF. Find angle FDE. This angle I need to find. Okay. No midpoint or nothing is given, but this is given 50 degree, which is weird. So no sine theta cos theta, no trigonometry. Nothing is given parallel, but I know these two angles will be equal for sure. So I know this angle will be 180 degree minus 2 pi. This angle and this angle has to be equal. So I know this angle will be 180 minus 2 phi, whatever this is. So I know these will be 180. So 180 minus 2 pi plus 180 minus 2 alpha plus theta should be 180 degree. 180 degree. 180 will get cancelled. 180 will stay here. Minus 2 phi minus 2 alpha plus theta is 0. 2 phi plus 2 minus this is 180 degree. So I'm getting somewhere. Okay, this I got. How to use this 50 degree, no? Alpha plus phi plus 50 degree has to be 180 degree. 8, 130 degree. Alpha plus phi. Okay, put it here. So 2 into 130 degree. Hey, got the answer. Just about playing with numbers. But don't be in a rush so that you don't make calculation mistake. 9 should be C. Yeah. Good question though. Let's do question number 10. A triangle is drawn with its vertices on a circle C. A triangle is drawn with its vertices on a circle C. Better to make a circle then. And then draw the triangle ABC. This is circle C, such that one of its sides is the diameter of C. One of its sides is the diameter. Okay. There's a circle. One of the sides is the diameter. So now you definitely know this is 90 degree and this is diameter. This is what the question is saying. Other two sides are in the ratio. So this is one side. Other two sides are A is to B ratio. If the radius is R, find the area. Because it is ratio, I will take it AX and BX. So first thing that I know is for sure x square, A square plus B square is R, 2R square, 4R square. This is one that I know. And I need to find the area of this triangle, which is half into ABX square. I know this. And I don't need X. X is what I assumed. Let's eliminate X. Looks pretty easy actually. 2ABR square upon A square plus B square. Is there an option? 2ABR square upon C 10th B. Yeah. Very, very low hanging fruit and it actually came in CAT 2023. So you can imagine geometry is so manageable if you look at it. ABCD is a trapezium. Okay. Such that AB is parallel to CD. AD is perpendicular to AB. AD is perpendicular to A. Okay. So this is basically like this. AD is perpendicular to AB and AB is thrice of CD. AB is actually the bigger one. So AB is thrice of CD. AB should be, it should be like this. Then this is X and this is 3X. If a circle is inscribed in the trapezium, one of radius 3, find the area of the trapezium. So area of trapezium is half of sum of parallel sides into height h, and h is basically what? 3 and 3, 6. So this is basically 12x. I need to find x. Any tangent always makes perpendicular, right? So I know this is definitely 6. Let's look at the diagram. Got it. This is the diagram. And this is x. This is 3x. And this is 3. So this is also 3. This is also 3. So this is x minus 3. Somewhere we have to put Pythagoras theorem for sure. This is 6. This is 3. So can I say this is 3x minus 3? Okay. And can I say this is x minus 3? So this is 3x minus 3 minus x minus 3 or minus 3 plus 3. 2x. Yeah. So this is 2x. Since this is 2x and this is 3x minus 3, tangents from same point are equal. This is also 3x minus 3. This is also x minus 3. So now if you look at this triangle, this is 4x minus 6. This is 2x. This is 6. Let's put Pythagoras theorem. Can I say 36 plus 4x square is 4x minus 6 whole square? Or can I take 4 common? Yeah. 9, 18, 27, 36. Take 2 out, it will become 4. 4x square plus 9 minus 12x is x square plus 9. 3x square is equal to 12x. So we are on the right path. X is 4. But answer is area was sum of parallel sides 3x plus x into height is 6. So 12x. So 12 into 4. 12, 24, 36, 48. Answer should be C. Yeah. Good question. Once you get comfortable with making good diagram, you can play around because you know that I can only use this information tangent from a single point. So you can see that this side and this side will be equal. You could have made a mistake of assuming this to be 2x, but this is not the tangent. This whole thing is the tangent. Let's go to question number 12. In a triangle ABC, AB and AC are equal and they're both 8. A circle is drawn with BC as diameter passing through A. BC as diameter, okay. So since this is a diameter, another circle centered at A passes through B and C. It has to be a bigger circle. Find the area of this overlapping region. This is the overlapping region between the two circles. Okay. So first of all, let's make a better diagram. I know that BC is the diameter. Since this is the diameter, 1,000 is the bigger circle and A is the center of this circle. So since it is passing through B and C, A is the center. So A has to AB and AC has to be equal, which is already given. Right. So A should be overlapping the smaller circle because AB and AC are equal. And it is drawn around A, right? So now that I know this is 8 and this is 8 and this become an isosceles triangle. So if I make this, this will also be 90 degree. So this is also, these two will be equal, right? So if these two are equal, so 8 by root 2 is 4 root 2. So I got this 4 root 2 and the bigger circle. Can I say area of the bigger triangle, bigger circle will be pi r square and area of the smaller circle will be pi r square or 16 to the 32 pi and this is 64 pi, correct? Area of the triangle also I can get half into base. Base is what? 8 root 2 into height. So 2 and 2 will get cancelled. 8, 16, 24, 36. So I know area of the triangle. I know area of smaller circle and area of the bigger circle. Sorry, 8, 16, 24, 32. Okay, let's look at that one by one. In this triangle, I need this and I need this, right? This and this if I get. Let's look at this ABC. I know the area of ABC will be half of, let's take it at point O. AOC will be half of ABC. This is 16 and this is basically a segment and I know the area radius also 4 root 2. So 1/4 of pi r square, 1/4 of the area of this entire smaller circle, 32 pi. If I subtract the area of this triangle, 16, can I get this? So this is basically 1 and 18, 9 pi minus 16. Can I say that? Sorry, 8 pi minus 16. Similarly, this will be area of the smaller circle minus area of the triangle, which will be 8 pi minus 16. And if you look at this, this is basically 1/4 of the bigger circle. So can I say this entire thing will be, this whole thing will be 32 pi, sorry, 64 pi by 4 or 16 pi, correct? And this entire thing is the overlapping region. So 8 pi minus 16 plus 8 pi minus 16 plus 16 pi should be the area of the overlapping region. 16 pi plus 16 pi is 32 pi minus 32. Option number B. Yeah. So now that you get comfortable with how to find the area of this segment, at the end this was one segment, two segment, three segment and this triangle, and I could directly see this segment and the triangle together. So these were the standards of CAT, and we kind of saw that it is quite manageable once we get a clear idea about the diagram and we use the information that we have. Next, we will move to advanced questions, and I think once we go through the advanced question, we can be sure that we are ready for geometry related questions, and they are very, very scoring. So if you get some level of comfort with geometry, go to level 3 as well. All right, thank you so much and happy learning.